live from New York. It's Ask an Engineer, where
Hey.
it's all rainbows.
Oh, it's all rainbows. We're in rainbows. Great. It's me, Ladyada, the engineer, with me, Mr. Ladyada, on camera control, doing the videos, doing chats, getting questions, doing pretty much everything for the show. So I just get to show up and present my pretty face. We got an exciting show, a lot of fun new products, Tariff Talk on MPI, lots of new stuff coming out, questions answered, and more. Let's get right into it. Mr. Ladyada, what is on tonight's show? What's the code? Because people want 10% off.
The code is enclosure, 10% off in the Adafruit store all the way up to 11:59 p.m. Use it or lose it. You never know what's going to happen with currency and economies and more. This is you paying for something that we would send to you. You can get 10% off. I just want to say thank you to Liz, who just did show and tell. We'll talk briefly about next week's show and tell and more. We'll do a recap from the desk of Ladyada, including the great search from over the weekend. We got JP's product pick of the week, a little bit of open source hardware, including our learning system, some 3D printing stuff, and a very fun one. It was a special request by me. Thank you, Pedro. We'll talk about that a little later. We got Eye on MPI, brought to you by DigiKey. This week, it is Texas Instruments. We got new products. We got top secret. We're going to answer your questions. We do that on Discord, adafruit.it/Discord. All that and more on, you guessed it. It's Ask an Engineer. All right. So just real quick, if you are putting stuff in your cart in addition to the code being enclosure, you'll notice you get closer to free stuff. If you're in New York before 11 a.m., you get same-day shipping. If you want to do that, just make sure that you know there is a fee, and just make sure you're around. So far, it's been working out great. In fact, we have more same-day now that we've moved to Brooklyn than we did in Manhattan. I think we're just getting the word out more. I do want to say one thing before we go into Tariff Talk, because that's the urgent matter at hand. I do want to say Happy Mother's Day, everyone out there. We did post something. We don't post personal stuff or family stuff, but this one I could. So what's the best gift you could give someone? Time. What's the other gift you can give someone? The ability to sleep, which is essentially the same as time. So from all of the engineering that we all love that Ladyada does, there's a flip side, which is I love sleeping. The more that a lot, the more rest and good food she gets, the more engineering that happens. And I think
pad thai in, engineering out. Yeah, that's the rule.
So I want to say Happy Mother's Day to all the moms out there, and especially to Lamore. There she is with her daughter, little baby Ada, for what we call her here on the shows and more. And what a cool little kid. She wants to already be a paleontologist, and she's 2. So that's neat. But I think every kid goes through that phase at some point. So anyways, Happy Mother's Day. So let's do Tariff Talk. Tariff Talk. Tariff Talk. Tariff Talk. Tariff Talk. All right. So Tariff Talk.
I had a lot of Tariff Talks today.
Yeah. So here's the thing.
Okay.
Let's just get it over with.
What?
We wanted to wait until we had a specific invoice from DHL or any other importer that we could show, here's what the new costs are.
And we did.
We
actually gotten other very large tariff bills. We got one for $20,000. I got one for $11,000. Again, for things that I was not expecting to have COO China. But this is still the biggest one, $36K.
36,000 will wait, but wait, there's more. So.
And people are like, yeah, but what was it before? Over. Like, if it was going to be, it's always been 36, then what's the big deal? Why are you complaining? Well, we have a graph.
Oh,
just the graph?
Yeah, so the graph, and maybe you can explain it. I'm going to go over to, I'm going to take care of something in a second.
Yeah, go.
So while you do the graph, and I take care of this thing with the discount code. Speaking of discount codes, my head is just filled with codes that this invoice was like one of the first ones anyone saw, because everyone was just saying and speculating we actually did it. So this invoice was on USA Today. It was on the front page of Reddit. All these places. There's people that I've known for years, and they never really said anything about Adafruit, but this was like, hey, you are on the front page of Reddit.
Yeah.
So that was the achievement, but I'm going to go to the chart and go take care of this thing. I'll be right back.
Thanks. Okay, so this is the chart. which we can duck down. So this, we don't have. We're going to get logs for previous data, but this is from the last year, and so you can see it's not like we've never had to pay tariffs, but usually per week it's like $5,000, and then maybe during the holiday season it bumped up a little bit. A couple of weeks we had some low weeks, some high weeks, because people would be off for the week and they wouldn't necessarily do purchasing or receiving. But it was always around like 5 to 10K, depending on what we bought. And then, basically starting in February, it started rocketing up. And, it's a challenge because the question is whether to not ship this stuff. Now we have this possible 90-day change in tariff rate. It's funny, people, I was talking to this journalist and they're like, aren't you relieved? And I'm like, I haven't actually gotten any guidance from Customs and Border Protection. Like, I actually don't know what the tariff rate's going to be.
Hey, look, we even have a text view of it. Oh, that's too tiny to see. Okay, fine, I'll zoom in.
Zoom in.
Okay. And that's the chart. See, that's what the chart is. Like, that is that. So look, check. That is that.
So I went from
is that
five, the shipment, like for the example, like some people are like, what was that shipment before? Okay, I don't know offhand because I didn't go back and do the back calculation, but probably would have been like 5 to 6K max. And it's not just China origin items, because we do buy stuff from other countries. There's a lot of if you think about it, there's a lot of popular products people buy that don't come from China, that come from other countries. And they're expensive, and they're now being tariffed at 10%, if not more. And so, it's not just like China, like you must be buying everything from China. A lot of electronic components and goods and connectors, and wires, whatever, and cables come from China, true. But there's also a lot of electronic products that come from Taiwan, that come from Europe, that come from England, that come from other parts of East Asia, come from Japan. And all those items are now also tariffed at 10 or higher percent. And so it's across like a broad swath. And people are like, well, why did you buy from this factory? This company that I bought from is not a factory. They're a vendor. They're not from China. So some of their products, their products are made all over the world. Some things got tariffed at 10%, some at 25%, some at 157%. I think one was 172. That was the max. One item got like tariffed. So, I think, and then, I had a couple people email and say like, well, why don't you name and shame? Like, who is this company? And I purposefully did not put identifying data so that people could figure out who this vendor is, because it is not useful to pile on to this company whose fault it's not, because we booked this stuff many, many, many months ago. They shipped, I didn't know necessarily that some of the stuff was pseudo China. I probably should have asked, but it was, the shipment was booked ahead of time. It's not their fault. They're working on finding other vendors that, or other factories that they can use. But this stuff was manufactured like 6-8 months ago, right? Like they had stock that we purchased. So, I don't want to, turn this into a pile-on of like who's making what where and like why are they making stuff in China when, China has been where a lot of manufacturers are doing electronic manufacture. A lot of tools and components come from there. Will things change? I don't know. Hopefully. Is there anything I can do about it? Not much. We're looking at sourcing components and tools from other countries, but unfortunately, there's not a lot of competition from other countries. Maybe there will be. That would be great. Like I said, we buy a lot of stuff from other countries, and those are now being tariffed at 10%, and that's a lot. If you think about like how much stuff we buy.
Plus other costs and inflation, and just things costing more over the last few years. So.
Yeah. But I think that's it. I mean, this is not an. It's interesting. Some people are like, why are you making political posts? This is not political. This is factual.
No.
I'm not putting even a value judgment on it. Because somebody was like, is this good or bad for Adafruit? And I'm like, well, it's expensive right now, but
yeah,
I don't know whether it's good or bad yet. It's way too early.
So we're reporting the facts. This is what the tariff amount is from DHL. It's
for
a fact.
One shipment, yeah.
It's a fact.
I got the bill. I paid it.
And we're purposely making sure that we don't have anything for a political football But I understand if that's your lens, if you're very left-leaning, very right-leaning, you'll see this in different ways. It doesn't matter, because the only thing that matters is we want to continue to ship the best open source educational electronics to the most people, and we'll figure out a way to get over, under, through whatever the next crisis is. We'll get smarter, we'll get better. We'll meet more people. We're meeting with lots of people in Brooklyn, in New York State, in the government, in other places. Everyone wants help. And I think we have, right after Asking NG, the idea is you'll be able to get an Ada box at the price that we can sell it based on all the things going on at that second. The time that's actually possible to ship it. So it's in hand, we have it in hand. And you can choose to pass, whatever. And there's nobody who can just squat on these. So it's just basically like a small little, hey, here's $5 and you get $5 back when you buy the Ada box, or it's a discount code. But it's essentially a little buyer's club. And that's just one of the benefits. And it's just a really lightweight way to just say, okay, people can't squat on the Ada box list. They have to do something, but then they can choose if they want that Ada box. And we're just going to call it flow. Lots of things that go into this. I have to see what happens with credit card processing. That means we get international. There's batteries. There's all sorts of stuff. And that is why I shouldn't type things into prompts. Okay, let's go to Desk of Ladyada. We did some stuff. We brought back the dig button, sort of. We were talking about that, and we also had a great search. And you had, I think it was that's a Claude thing. That's a codex thing. That's a thing.
Oh yeah, because I was showing off codex.
Yeah. So what did you do on Desk of Ladyada?
Desk of Ladyada, I showed off all the prototypes that I designed recently, and then I tried codex. I didn't like it. I'm getting some boards out the door. So this week you saw, you'll see we have 2 Adafruit products in the store. A lot of shipments are still being delayed. And we're also getting stuff is coming through customs. It's taking a while. So it's going to be another week or two till you see products start, more products come into the shop. There's a little bit of slowdown, but there will be a little bit of a buildup. And then, come by every Sunday-ish and you'll see me do what I do best, which is engineering.
Yeah, for the folks who, so there's different streaming networks that are a little laggy. There's really severe weather here in New York. But just by the way, infrastructure is collapsing.
Okay.
Yeah, that's what's going on. Watch the news. And JP's workshop is every single Tuesday, where you can buy the product right off the product page. JP will now show this week's highlight.
The Pico Bell Ada Logger. It is for logging your data. It has a micro SD card over SPI. It has a STEMMA QT port for attaching sensors, and it has a real-time clock with battery backup. Got the Pico 2, I've got the Ada Logger. You can see I have the coin cell battery in there. I have STEMMA QT plugged into an SHT 45 humidity and temperature sensor, and then I've got my little SD card plugged in there to log data. Every 30 seconds, you'll see a little LED light up on the Pico. Oh, it just went. It means it just wrote some data. Looks something like this plotted, in this case, inside of Google Sheets. This is a few hours. I had this running overnight. Pico Bell Ada Logger with real-time clock, micro SD card storage, and STEMMA QT connector, all in a neat little Pico and Pico 2 flavored package.
Will it hurt if I remove that mask? It'll be painful. You're a big boy. You can handle it. Anyways, I sent it to JP. I think he was nervous because he said, "Hey, my thumbnail this week is Bane," and I said that was painful. And he's like, "Oh, I go for you." But I think he knew that pop culture reference because that's what we trade in sometimes.
Yeah.
So 3D Hangouts on Wednesdays, and then, of course, Deep Dive with Tim on Fridays. Some open source hardware stuff going on, Ladyada. Let's go jump to the learning system. How many guides do we have?
A lot of guides this week.
Do we?
Yeah, a lot of them came out this week and got them going. So starting off, we've got new in IO, we've got Blockly actions. So actions are things that you can do when a feed changes. And historically, it was you could send an email, or you could write to another feed, or you could send an SMS. But it was really restrictive because we had to have a dialog box, and you would just select like the thing that you wanted to do, we wanted to make it more flexible so people could actually create like pretty complicated IoT codeless projects. So like, especially since we have Whippersnapper, right? So you have no code ways of connecting hardware to the internet and Adafruit.io. So trying to write guides with Blockly Action. So this is a no code, no solder guide with a Raspberry Pi Pico 2W. So it's like a low cost Wi-Fi chip, a door sensor, and I'll send you an email when the door opens. Like it's like an actually fairly simple project, right? But the cool thing is that you don't have to write any code. It's all done with like just drag and drop blocks. Do you actually like going to, I want to show the blocks.
Which blocks would you like to go to?
Well, you go to the browser and you click on the guide.
You want to go to this one?
Yeah. I'll just show the blocks real fast. And click on create an action. And then scroll down. So this is like how you do stuff. If you scroll, you hit, you might want to have you disappear us because we're gigantic. Okay. And then keeps going down.
This way?
No, because that's like the demo shot. Yes, keep scrolling. And then, yeah, you like drag and drop to click the feeds in for like, okay, when this feed changes, and then if you keep going down,
yeah,
you drag, you can select which feed and then keep going. And then you just drag over an email or an SMS block or a webhook. So
nice.
Kind of neat, really complicated. You can do math. Yeah. And you can do like search string, like you can do like complicated functions. And I remember like doing projects that would require like setting up an AWS Lambda. And it was like, all I want to do is like take a substring and like add a number to it. And it was like, no, you can't, there's no way to do that without either having a microcontroller do all the work or, like I said, having a Lambda do it. So this is pretty cool. Okay.
So here's the thing, folks. I'm just going to call it, the way computer science is going with as far as like end users, like doing computer science, a lot of it's going to be, voice prompting at some point. And then you'll see block coding. And then you'll see people doing, code and IDE with all sorts of Copilot-y like things, but things are changing. So the IoT stuff in particular, the glue is nearly impossible just to see in a text format. So I use the Claude MCP and I use Zapier, and I have an AI look at our product feed, and I have it do things like look at words and find stuff. Like it's just like analysis, but I need it to go and do smart things with a chunk of data. So it's neat because these two things go together. And the only way to do it is to put these blocks together.
Yeah.
It's very similar. We're all just living in a block world.
Okay. So yeah, go back to the guides.
I'm going to go back to the guides.
Yeah. Thank you. Okay. Back one more. Okay. And then we've got this cool butterfly bench. We got the little video that we're going to play.
We're going to play video.
So go back.
Yeah.
You have to click on the guide.
Yeah.
Minesweeper on the Metro. So this is a remake in CircuitPython that you can display on a monitor and use a mouse. So on a RP2350, you can do video output and USB input. And go back.
Okay. Beep boop.
And then big guide for the motorized slider camera. I don't think you have the video though, right?
Not yet. I don't think so.
Okay.
I think we played it maybe as a thing. I think it was a short. I don't know.
Yeah, I don't know why
this is new. World Clock's new.
World Clock. Yeah, this
That's
project
nice.
that shows the world as, what's light
nice
in the world. As
okay,
it
cool.
rotates. Go back one. I think that's it.
Red.
Yeah,
now
that's
we
it.
did the other ones. Okay, cool. And then, while we are here, playgrounds, other stuff, just check it out, please.
Yeah, I don't know if there's anything new.
There is, but we gotta go. Let's play the video with Aaron. Thank you, Aaron, for making this wonderful butterfly video by the wire.
Build an LED butterfly bench out of plywood and edge-lit acrylic. Add beautiful animations with the Adafruit Sparkle Motion Board and NeoPixel strips. Program and control your lights with WLED and easy-to-use smartphone app. Your backyard will never be the same. This bench is made to bring to festivals or on camping trips. It packs flat and assembles in moments with no hardware required. See the full build tutorial at learn.adafruit.com and remember to subscribe for more gorgeous LED projects.
don't forget our code is enclosure 10% off and if restore all the way up to 11:59 p.m. Eastern time, 3D printing time. Okay. So much now, Pedro. They have a speed up. These are little fun plastic cardboard cutting tools, but they're not sharp because our kiddo likes to build stuff, and we built stuff already, and I wanted to have a whole set of cardboard tools for her, and we're gonna make them. All right, and I just want to point out that you can get those on Amazon. You used to be able to get them for like $4.99, but now since the tariffs, they're $2,000. So it's cheaper to just 3D print them and
on your 3D printer that also got tariffed,
and then 3D print
$3,000,
and then 3D print a yacht and just 3D print some fuel. And
wait till you find where the filament comes from.
Where'd the filament come from?
It comes from China.
Oh no!
Not all of it, but
Can't we just
low cost stuff.
Can't we just mine a asteroid and get filament?
Yeah, could recycle. All right, let's keep
Okay.
going. Let's keep going.
All right. So anywho, let's jump right over to INPI. Are you ready, Ladyada?
Yep.
on NPI.
Hi, on DigiKey, brought to you by DigiKey and Adafruit. This week it is Texas Instruments. Ladyada, what is the new product introduction of the week?
Okay.
This week.
This is INPI, not INDigiKey. We were so fast. Okay.
I
on NPI.
on NPI.
Okay, this week's
oh my God.
This week's NPI is
I'm so tired.
I know,
so
that's
sorry.
why I'm backing you up here.
No.
It's the BQ
Strong start.
25798. I think I got that part number right. Yeah. Okay, cool. This is a follow-up. Actually, a couple years ago, we covered the BQ 25792, which was a very similar I2C controlled 1-to-4 cell 5 amp buck boost charger. This one improves on that previous version in that it can now do solar MPPT, max power point tracking, true max power point tracking, and has dual input selector, which is handy if, again, you have a solar panel. So what I like is, it's a very simple board, actually, a very simple chip, not a lot of components needed. You can use any kind of lithium ion or lithium polymer battery from 1S, so like 3.7, 4.2, up to 4S, which is 4.2 times 4, so like what's so big battery packs used for like scooters and stuff. So like, really big boost converter built in, so it's very voltage input is. Did again a couple of years ago. The same, it's like 3 to 25 volts in, but it backup mode to do having a buck boost converter means from 4 to 24 volts or so. It'll automatically, like, you don't have to worry about making sure people like usually we have linear chargers, and so if you're charging 5 volts, if you're charging a 2, but that's annoying because what if somebody only has USB? In this case, it would just boost the voltage up to charge whatever size battery you've got. Graphs. I'll note that you can select, on the next page when I show the resistor selector, you select which battery size you're going to use. 750 kilohertz or 1.5 megahertz. 1.5 megahertz, you'll use smaller capacitors and inductors. but it's less efficient. So, if you don't mind having a larger build and efficiency is more important, maybe because you are doing a lot of solar stuff where efficiency really counts because you don't get power when it's cloudy or when it's dark. So you want to like maximize when you do, go with the 750K. There is I2C control on this, and we'll talk about that in a bit. But what you can do, it can actually charge stuff like autonomously, which is kind of handy. So you don't have to I2C configure it, like if the battery's dead or if your main controller is asleep. So just plugging it in will autonomously power it. You set the frequency for the buck boost and the cell count using one resistor. You set the current limiting with another resistor called like ILIM. And then the neat thing, so it's all like another resistor called like ILIM. And then the neat thing, so it's all like, like I said, it's in the 92. The cool thing is solar. So we've got some solar boards, but to be honest, none of the boards we have so far are true max power point. They do a little bit of trickery to get really close to max power point, but especially with the buck boost converter, you can't just like use the lowest, highest voltage to get you the most current. You actually have to do this like thing where you try a variation of voltages around a certain set point to find out like where you are on the curve. To do solar, what they recommend is there's two inputs. There's AC1, AC2. One of them is going to be a power supply, like your AC or USB power supply, and the other will be solar, so you have a backup. And then because there's a buck boost, you can't just use a simple O-ring diode configuration. If you think about it, you don't know, just because something has a high. So there is like this kind of like ideal diode. Default, I think it like always just goes with, AC1 over AC2, but you can tell it which one to prioritize. So if DC is plugged in, it'll go to DC, and if DC isn't plugged in, it'll go back to solar. Or you can use USB in DC. So you can enable max power point. You don't want to enable it unless you're having a solar panel because it acts very weird for DC. A solar panel basically will give you a max voltage when there's no current. And then as you draw more current, the voltage starts dropping. And then if you draw too much current, if you get past that peak, it collapses, right? Because you're drawing too much current. So there is this like one point in the middle where you're going to get the most wattage. That's not like necessarily the highest voltage. It might not even be the highest current, but it'll be like the figure out where that point is, and the algorithm that you need to do for max power point kind of like you set volts above 1.1 volts below until you get the max power point. So it use simple voltage limit for you. There's a presentation from TI. They go through. There's a number that you say, like, you'll get like very good output, like even at the for your solar panel, you'll still get 12. Tweaked it right, so they do. The boost, the buck boost, there's so many different, as you move, you're going to get varying efficiencies linked from the INPI tech, or once an hour or whatever, if you want to really optimal max power point for the battery size and panel size that you're using. It's like, it'll get you 80%, 90% of the way. There's also some cool things that, were in the 92 that are still in the 98. I like the ADC can monitor voltages and current to let you know how your battery's doing. I'm a little bit like, it's kind of cool, but it's also, you have to make sure that the power is disconnected. Like if there's no power coming in from the USB battery, you can request for it to like go into back battery. the battery is buck boosted to create a voltage, and you can set what voltage you want from like 5 to. Again, you can't do it when the power, like obviously you can't do charge something while it's charging. You're going to want to have a separate voltage converter. The block diagram shows it's a fairly complicated chip inside, even though there's not a lot of pins accessible to the outside. You're going to want to use I2C to configure it. You really, to get the best use you're going to want, especially with the Max PowerPoint config, because you have to enable it. So you'll need I2C. But the good news is that the SDA and SCL pin are 5 volts compatible and 3 volt compatible. You can run this. I looked at the register map. You could probably run this on an Arduino or a Raspberry Pi, whatever. Even a small, AT Tiny microcontroller could probably get you going if you wanted like the minimal controller for your solar setup. But this is meant to be integrated into like a bigger product where you already have a microcontroller. Basically, like here's the schematic. You don't need that many parts. You just want to set the voltage. You need that microcontroller host, and if you want to do, you can set up that ideal diode with back-to-back FETs that it can select which voltage is the input. Comes in a fan. It has these weird pads are the power pins, because again, you get 5 amps. 29, right? Only 29. Only 4x4 millimeters. I like that's not BGA. Thank you. And it's in stock, and it's cheap. It's like $250. It's like the price of like an off-the-shelf linear charger, but you get like a full buck boost and MPPT. It's just like amazing.
Yeah.
Amazing. Normally you'd have to have like 6 chips. I like this. I'm going to get ready for it.
Apologies for the, I misspoke. It was, Ion MPI.
Yeah.
Brought to you by DigiKey.
Yeah.
So, it was funny. Just a little side note before we end this.
Yeah.
I was doing some speech to text thing.
Yeah.
And it kept doing
mistakes.
It kept doing mistakes, and I thought it was a typo, but it's not because I didn't type anything.
Right.
And
what would you call that?
Well, I didn't misspeak. I didn't pronounce something wrong. It's just sometimes the word is in there. Like if I say Lemore, it'll say Lee Moore, and it'll say Lee and space More. So what I do now, because I've seen so many people do this, like all over, is I put a little taco. And if you put a taco, that means like some of this was speech to text, and it's taco, TALKO. But when you say taco, a taco comes out. So in itself is indicating what it is.
Not typo, a taco.
A taco. Okay. Yeah. And
you learned something this on the site.
The person who Janet, who you went to MIT with, she's the one who's coined this phrase.
Yeah, she's famous.
So anyways, taco. I feel like, every time I'm around all these engineers, I'm amongst gods. So anyways, that's this week's Ion NPI, brought to you by DigiKey. Thanks so much, DigiKey. And thanks, Janet, for bringing tacos to everyone. I'm sorry, tacos.
On NPI.
It's all rainbows and puppies here. Boy, that tariff bill's big.
Yeah.
Yeah, and we don't even have expensive tastes, and
it's like a minor yacht.
We could
not even have a Tesla. I have like a bike with like a flat tire.
We cut close to the bone because we really want our employees to have a great life. We want our community to have access to low cost educational electronics. This is hard. So buy stuff. Anyways, want to do some new products?
Yeah.
Okay.
Some new products.
You wanted me to start with a different one first? This one?
Okay. So, like I said,
just point.
I did point.
Yeah, no, I'm saying going forward, if these are out of an order that I did wrong.
I did.
Okay.
Yeah, definitely.
Great.
It's great.
Okay.
Got a couple of products in this week. You'll see more coming soon as our shipments start arriving, and hopefully they're not tariffed excessively, so we can put them in the store at a good price. Like this is a Sen 66 adapter board. That's the board in the center there. As you see, it converts the Sensorion Sen66. Wow, that was featured last week on IMPI. Maybe you guys picked one up. You should. It's a really cool all-in-one air quality sensor. But then you're like, man, I want to connect that to my microcontroller, my Raspberry Pi. How do I do that? Well, you're in luck. Pick up the Adafruit Sen66 or Sen X, because there's other in that family. They're all pin compatible. You also have the GH cable in stock. You plug it in, you connect it. It does all the level shifting for you, power regulation. And now you can connect it to any 5-volt or 3-volt microcontroller. And then you run Sensorion's I2C code for Arduino or Raspberry Pi or Linux or embedded, what have you. And you got like this amazing all-in-one air quality sensor. Plug and play, no soldering required.
Yeah, okay. Which one do you want to get to next one, Mark?
Okay, next up is, people watched me design this on Desk Ladyada. Now it's out in the world.
I know I did.
You did. It's a Sparkle Motion stick. That's a weird shape, so just don't worry about that yet. But it's a USB plug stick. It has terminal blocks on the end, so it's fully assembled. And it's meant to be used with WLED, although to be honest, you could use it with Arduino, CircuitPython, MicroPython, whatever, ESP IDF. And it does this. You plug into USB and it has wireless, like Wi-Fi and Bluetooth energy control of NeoPixel LEDs. 5 volts up to 2 amps. And the cool thing about this board is it has lots of extras. So like that black blobby thing near the USB, that's infrared input. So you can use a remote control. WLED has great support for infrared. There's a microphone, which if you look on the back, there's an ESP32. We use like a classic ESP32 because that's the best supported. It has an I2S microphone for great audio input. And it's got terminal blocks with 5-volt ground and 2 outputs. There's also a built-in NeoPixel LED if you want to use a NeoPixel. It has a built-in USB serial converter with auto reset. Has a level shifting on the output, so they're 5 volts. So it'll run like any kind of weird NeoPixel-y thing. And then you're like, wow, this is really cool, but why is it that weird shape? And don't you have like some sort of enclosure you can put it in? Why? You're in luck, because the star show is the version with an enclosure. You get $1 off if you buy it with an enclosure. This is a snap-on enclosure that we put in the shop a couple weeks ago.
Did we say it's snappy? Because that's too easy.
It's snappy. The both pieces snap on. Oh, and there's a button in the center which you can use for changing modes. So in the little GIF, it's used to turn on and off, but you can have it change modes.
It's true.
I recommend getting it with a stick. So it's a little plastic enclosure. The button works on it, which is awesome because you can still use it for modes. The terminal blocks come out, but they don't stick out too much. Comes a little protector, and you can toss it into your bag. I think this is great for like portable projects where you want to do WLED, because you can just plug it into any USB battery pack. So whatever you use to charge your phone when you're traveling, plug it in, and now you've got a portable, easy to recharge WLED project. You don't have to worry with like lithium-ion batteries and charging and swapping. You can also plug it into the wall. I saw this as like a Christmas tree kit, something like this, but not nearly as cool, where you had an LED strand on the end of it and you could like decorate your tree. I was like, oh yeah, just have it plugged into the wall, and then you just have the strand come out. So I thought it was very, very convenient. So I'll say it's at a good price. The price might go up if some of the components start getting tariffed heavily. Right now we had those components on hand, so you're in luck. I would pick up one of these with the enclosure. They're really great for making WLED or X lights, or really anything NeoPixel projects with wireless Wi-Fi, Bluetooth, and Bluetooth Low Energy. New.
Okay, cool. We're going to top secret, then we're going to answer your questions. We have some questions that were already posted up online and more, and we'll go to Discord. Let's do some top secret. Okay, first up, we're going to watch a video. It's about 2 minutes long, and then we're going to look at 3 boards that Ladyada has is coming soon, and then a little bit of a preview, a 10-second preview of our video game, The Great Search, that you'll be able to have access to starting next week. We're not messing around. Okay, be back in a second. Well, 2 minutes. Ladyada, what is this?
Okay, so I'm working on this OPT 4048 Tristimulus sensor. This is a color sensor that can read RGB data and then decode it into CIE, X, and Y. So that's useful for like when you want to do like chromacity or color temperature and lux sensing. So, I got it working with the library that I wrote, and that's all well and good. But then I was like, man, I wish I had like a way to plot the data. And so normally, plotting data, especially on like a just like XY Arduino plotter, is really complicated. But I worked with Claude and we made this cool JavaScript page. So if you come out, you'll see. This is actually hosted on GitHub. So what's nice is that it's all JavaScript, hosted on GitHub, and it uses Web Serial so I can connect to this device, and then the Arduino sketch prints out the data, and then it's plotted here really nicely. So the CIE, the lux, the temperature. I'm kind of moving it around so it's jumping. But it's, kind of like a warm white color. And then, I was testing this and I was like, well, how do I test other light colors? I don't actually have any gels here. I was like, oh yeah, I could just like put the sensor up against it and you'll see that the little dot follows it around.
It's training itself on synthetic data.
I know, it's funny. So this is really neat because something like this web page would have taken me like, I know JavaScript, I could do it, but it would have taken me like days. This only took like 25, 30 minutes.
You got hardware to make.
Go back and forth. Yeah, I can focus on the hardware. And so what's neat is I'm thinking like maybe we'll do this for more products whenever we want to plot or show the data. Instead of just having the Arduino or CircuitPython REPL output, maybe we'll just say, hey, look, connect it up to this GitHub hosted Web Serial demo. And you can really quickly test the sensor and get real data out. It's like, it used to be when you bought dev boards from companies to do this, you had to run like Delphi programs that only run on Windows. So this is pretty amazing. I love it. So this sensor is going to be coming to the store soon.
Okay. What's this?
Okay, this is another INPI we covered a couple weeks ago. It's a really high lux sensor. So is the OPT4048, but this one is even higher. And so I thought nobody ever had said we have too many light sensors. So there's another light sensor.
Hi, Lux. Bye, Lux.
Bye, Lux. This is an I2 to UART converter. That'd be handy for like, you need hardware UART, but you only have I2C. And this chip isn't too expensive, so I thought I'd make a breakout for it. And this is, we cover this on the Great Search. This is an ideal diode. So it's more expensive than just a plain diode, but it has a very, very low forward voltage. And it has some cool extras like current monitoring, and you can enable and disable it. I'm going to use this for solar stuff, but it might be also useful for other people's power projects.
That's right. So next week or sooner, we'll see how it goes. I get off the air and I hit the news sites and it's just like, oh geez, I got to deal with fallen squids or something. Okay. I'll be charging up my squid grinder. Do you know where I put it? It's in storage.
Yeah, it's in the basement.
Yeah. So we have a game called The Great Search.
Mm-hmm.
Go to the Discord, the Adafruit Discord, where people are asking questions and going to give me medical advice because I just broke my wrist. I'm gonna claw. So what we're going to do is we're going to just give you the URL and a password. You'll be able to look it on the web. We're using Godot.
Yeah.
And then we'll have the iOS and Android versions, definitely Android versions. So that's how we're going to do it. Trevor will be there. Sound designer Dan will be there. And we'll probably just hang out. And we'll see. Everyone's going to use it. We'll see how it goes. Here's the thing. This is a community project together. We'll have like open source levels. Maybe we goofed on something and there's like an offensive billboard in the background. I don't know. Who knows, man? But if we do it together, then we can all celebrate the successes or not really take any blame because it's distributed. It's like, that little mat that I have that has a little nails in it? Mm-hmm. Like and if you were to go on one nail, it would be like a thumbtack. Mm-hmm. But if you distribute it across all the thumbtacks, it doesn't hurt so much. So anyways, that's coming soon. Stay tuned for that.
Okay. Do some questions.
problems. Okay, Ladyada, you ready? Why don't you read these so we can even go through them faster? Once you read them, you read them so people who are not seeing what's on the screen can hear it, and then I'll turn us on.
Okay.
Yeah.
Can you use the sensor to help calibrate a screen? Yes, that's actually what the sensor is designed for doing. It's for phones and monitors to calibrate them, especially when the light is changing, so you can make the screen look good and correct no matter what your ambient light is.
Okay, next up.
Okay, why bigger cut can't filter high frequency? It's because of the material it's made out of. Bigger capacitors tend to be made out of electrolytic foil capacitors, that are like, there's like 2 layers of foil with, I'm trying to remember the electrolytic gels inside, and it's curved around, and they just don't have very good high frequency response rates. It's just part of the physicalness of the capacitor. Where ceramic have very good high frequency rates, but because they're made with this MLCC process, the capacitance doesn't get much bigger than 100 microfarads.
Next up.
But it would be helpful to make a rover using this Feather RP2040 RFM LoRa. Like if I got 2 of these in a control center and one on the rover, would it be possible to control like an RC car? Yes, LoRa is great for RC. It's you don't need high data bandwidth because you're just sending it commands. You're not sending video or audio over it. So it'd be good for a rover.
Next up.
How to clean power noise from a PAM 8403 amp, power USB. I think I actually used the PAM 8304 and 8403. I didn't like it so much. I'm trying to remember one of them. One of them was like really noisy. The breakout we have in the store is pretty good. Make sure you don't have any ground loops. Make sure your wires are nice and short. If it doesn't work, put a ferrite bead between the power in. And if that doesn't work, maybe use like a 10 ohm resistor and then a big capacitor to try to clean it up. I don't know that it's USB. I'm thinking it's probably something else. Maybe your ground's not connected. Maybe your differential isn't grounded or something. It's probably not the USB power.
Definitely need some caps to smooth that out. Next up.
I have a power problem, an Arduino Uno, and a PCM 9685 board. I supply the Adafruit board with 5 volts, so I plug the power into 5 volts into the power pin. I get interference on my servo motors. When I plug the Arduino into the USB port, it works on interference. How do I avoid interference when using a single 5-volt power supply? Your power supply might not be very good. You might need a better power supply. Make sure it's 5-volt 2 amps, or even more. 5-volt 5 amps would be even better for a lot of servos. Try that, because what's happening is your servos, as they're activating, they're dipping the power supply. So you probably just need more current.
Okay, next up.
How to manage NTP daylight savings time, wintertime. Yeah, time zone, but only fixed TZ offsets and taking into account daylight savings time. Is there a complementary library that calculates the proper TZ offset according to the time zone? So this is an extraordinarily hard problem, because daylight savings time also change. The law can change, and depending where you are, like some cities and towns don't do it. Like parts of Indiana are one the other. Honestly, we use, if you have internet and you have NTP, we use a time service, and there's lots of time services that you can give it your coordinates, your zip code, and it will tell you the time. And like, I hate to say it, but like, just do that once a day to like synchronize yourself to like whether it's daylight savings, and then use NTP for the rest of the time. Like, that's probably my best suggestion, because it's psychotically hard. It's really, really hard.
And if you're building things, here's something that you should keep in mind. Time zones are probably going to change. Daylight saving times may or may not be around. Names of oceans may or may not change. And so will many other things.
There's actually also time zones they can do by IP address. They can tell you, like, based on what your IP address is, what your time zone is. So like, just do that.
Be flexible. Go with the flow.
Okay, good patterns for controlling timing of discrete LEDs. They have arbitrary discrete LEDs and blink and fade.